All right, on page 14. So I'm just going to read part of this, all right? So a radical expression, remember this is the radical sign, looks like this, contains a radical such as a square root. Remember, if there is no number in that little crook, we call that a square root, okay? A square root of a number is a value that when multiplied by itself gives the number. So we have 7 times 7 equals 49. So the square root of 49 is 7. A number like 49 is called a perfect square. Okay? A perfect square is a rational number with a square root that is a rational number. All right, so can you think of some perfect squares? Let me get you started. So if I have a perfect square, let's just write some of these over on the side. These are perfect squares. 1 is a perfect square. Okay. 4 is a perfect square. 9 is a perfect square. And how am I getting these numbers? Do you know? Why are those perfect squares? Well, if you think of a square has to be where all sides are the same. So a 1 by 1 square gives you 1. A 2 by 2 square gives you 4. A 3 by 3 square gives you 9. So what's the next perfect square in our number system? 16. And then we have Esme? Do you know? 5 times 5, which is? Anyone? 25. What's the next one? 6 times 6, which is? 36. 7 times 7, 49. So these are our perfect squares, okay? Because if you think of a square, it's a 2 by 2, a 3 by 3. It has to be the same length on both sides, okay? So the product property of square roots, we don't care about what it's called, but the square root of a times b is the square root of a times the square root of b, okay? The square root of a times b is the square root of a times the square root of b. Good morning. Thank you. All right. So in symbols, the square root of AB is square root of A times square root of B, where A and B cannot be equal to 0. So if you put and multiply two values together, the square root of 4 times 16, we can break those up separately. So the square root of 4, which is here separately, times the square root of 16, right here. The square root of 4 is 2, and the square root of 16 is 4, so 2 times 4 gives us 8. So it's just saying we can multiply them together, and then we can separate them and find the square root of each one individually. We are in our notes, Allie. In our notes with that kind of hot pink, sort of hot pink. Likewise, we're going to do the same thing when dividing, okay? So square root of a divided by b is the square root of a divided by the square root of b, which looks like this, okay? The square root of the whole thing, but we can divide it up. The square root of a divided by the square root of b, and we can find them individually. So the square root of 100 divided by 4, instead of looking at the whole thing, we can just say the square root of 25, because we know 100 divided by 4 is 25, and the square root of 25 is 5. Or, and that's a big or, we can look at each one individually and say the square root of 100 is 10. The square root of 4, whoops, meant to do that in blue, is 2. 10 divided by 2 is 5. You're still going to get the same answer. Okay? So these things are important here at the bottom. Put a couple of stars or circle it. A square root is in simplest form if these conditions are true. 1, the square root contains no perfect squares other than 1. Other than 1. All right? Number 2, the square root contains no fractions. So just say no to fractions. All right? No fractions. And number 3, there are no square roots in the denominator. No square roots in the denominator. So that would be like 2 divided by square root of 6. That is not in simplest form. We cannot do that. Okay? All right. Let's go on. Prime numbers. Prime numbers. Does anybody know what a prime number is? I bet you might have heard of prime numbers before, but I'm not sure if you know what it is. Prime numbers. Okay, well, here's the definition. A prime number is any number whose factors are only, and I want you to make big capital letters for only, any number whose factors are only 1 and itself. So a prime number, the definition is any number whose factors are only 1 and itself. Okay? And let me tell you, in case you're wondering, we do not look at 1 as a prime. So 1 is not a prime. Yes, I know 1 times 1 is 1, but it's kind of one of those odd ones. So, larger than the number 1, can you think of the next prime number in our number system? What do you think? Well, what's the next number higher than 1? 2. I knew you guys were smart. All right, so 2, what are the only factors of 2? What 2 numbers, whole numbers, can you multiply to get 2? 1 and 2. Is 1 and 2 the only factors that multiply to give you 2? Yeah. So that means 2 is our smallest prime number. Can you think of the next largest prime number? What's the next number? 3. What are factors of 3? 1 and 3. Are those the only 2 numbers that multiply to give us 3 as whole numbers? Yeah. All right. How about 4? Yeah, you can do 2 and 2. So 4 is not going to work. How about 5? Yeah. So 2, 3, 5. How about 6? No, because you can divide by 2 and 3, right? How about 7? Yes, 7, good. How about 8? What do you notice about all the other even numbers? They're always not going to be prime because you can always divide by 2, right? So we don't need to worry about any other even numbers. We just got to look at our odd ones. What about 9? 9 is a perfect square because 3 times 3 gives you 9. So not 9. How about 10? No, that's even. 11? Yeah, 11's prime. 12? No. 13? Yeah. 14? No. 15? No, because we can do 3 and 5. 16? 17? Yeah. 18? 19? 19, yeah. 20? No. I'm just going to stop there. Are there more? Oh, yeah, there's lots. I'm going to put and more, but we're not going to go through all of them, okay? These first, I'm going to say these first 4 are the main prime numbers that we are going to look at. Main numbers that we're looking at. 2, 3, 5, and 7. 2 is the only even prime number, okay? All right, so I just had a birthday a week ago Monday. We were on break. So this is quite appropriate that we are going to use the birthday cake method for prime factorization. All right? Now, I'm just going to read these steps. I don't need you to write anything. Step 1, when we are doing factorization, when we're taking the square root of something, write the starting number on the first layer of the cake. When you're making a cake, where's the first layer going to be? The bottom. Yes. So we're going to start here at the bottom. Maybe you could write bottom if you wanted. Step 2, on the outside of the first layer, write a prime number. Write a prime number that evenly divides into that bottom layer. Okay? And I'm going to give you some hints here. If your number is even, I want you to divide by the number 2. I want you to write that down. If your number is even, let's divide by the number 2. Okay? If your number ends, can't walk and talk at the same time. If your number ends in a 0 or a 5, then I want you to divide by the prime number 5. Okay? So if we have an even number, if it ends in 0, 2, 4, 6, or 8, you're going to divide by 2. If your number ends in a 0 or 5, I guess you could divide by 2 for 0, but let's divide by 5. And then try, if it doesn't end in 2 or 0, 5, try dividing by 3. So we're going to try to divide by these prime numbers, and these are 3 of the big rules that we're going to follow. So step 3, divide and write your answer as a second layer. We're going to divide and get numbers. On the outside of the second layer, write a prime number that divides evenly into the second. And we keep going up until we get to the top where we reach 1, and that's going to be our birthday candle. So step 6, repeat until you end up with a 1 on the top of the cake. This is the candle. Step 7, use the numbers on the outside layers to write your prime factorization. So this is prime factorization. Factors, remember, are just numbers that you multiply. So let's take a look at this. This says the square root of 18. Okay? We're going to start with the bottom layer. So we rewrite that number 18 on the bottom. And we are dividing. Okay? Dividing. 18, is that an odd or an even number? Even, because it ends in 8. And we said up here, if it's an even number, divide by 2. Okay? So over here, I'm going to divide by 2 because it's an even number. Okay? And 18 divided by 2 gives me what? Not 6, 9. Okay? And we are dividing again. I always want to divide. These are going to be prime factors. So I always want to divide by a prime number. Can't divide by 4 or 6 or 10 or any of those. Now, 9, is that an even number? No. Does it end in a 0 or 5? No. So let's try 3. Okay, divide by 3. Yes, that works. 9 divided by 3 is 3. Well, 3 is divisible by 3 also, right? So divide by 3 again, and we get 1. You are done when you reach 1 at the top, and that is your candle. Okay? So these are your prime factors. We rewrite our problem, square root of 18, and I'm going to do this over here, means the square root of 2 times 3 times 3. Okay? Is everybody with me so far? When you have 2 of the same numbers multiplied together, we know that this is forming a perfect square, right? Because it's 3 times 3. And we know 3 times 3 is 9, okay? But I am going to take this out. And remember, a perfect square has 2 numbers that are the same thing. We are going to kick that out on the outside. And so our final answer, we only take one of those 3 because it's a perfect square, is 3. 2 doesn't have a perfect square or another partner with it. So times the square root of 2. And that is your final answer. So for this part of the test, we are looking for you to do this cake method. All right? So some of you did this homework. You're going to have to redo it using the cake method. Okay? All right. Questions about this right now that you're like, I don't get it. Allie, you okay? All right. Might want to get a couple of these down. All right. Square root of 60. Okay? So rewrite this as the bottom part of your cake, down on the bottom. And this is not a square root sign, that's just dividing. Okay? Now, a couple ways we can do this to start with. Is 60 even? Yeah. 60 also ends in a 0 or a 5. So we can either divide by 2 or we can divide by 5. Let's divide by 2. I almost always like to divide by 2 or 3 if we can. So what is 60 divided by 2? 30. And 30, is that an even number? Yes. 30 divided by 2 is 15. 15 ends in a 5. So what prime number can I divide 15 by? 5. Could have done 3 also, and it doesn't matter. It doesn't matter because they'll all be the same. So 15 divided by 5 is 3. 3 is divisible by 3, and that gives me the 1. These over here are your prime factors. So you rewrite all of those numbers under your radical sign. And I like to put them in numerical order. So I've got 2 times 2 times 3 times 5. I have 2 2's. I'm going to circle those, okay, because that makes a perfect square of 4. This perfect square of 4 goes on the outside, but only 1 gets written down. So my answer here is 2 out in front times the square root. 3 doesn't have a perfect square with it. 5 doesn't have a partner. So we multiply these together and they stay inside under the radical sign. So your final answer here is 2 times the square root of 15. Okay? Let's look at the next one. Square root of 9. Now, maybe you know already that that's a perfect square. Maybe you don't. Let's do it using the cake method. Okay? So, start on the bottom layer. Hey, can I divide this by 9? Is that a prime number? No, because 3 times 3 is 9. So you always have to make sure you are only dividing by prime numbers. Is 9 even? No. Is 9 end in a 0 or 5? No. So divide by 3. 9 divided by 3 gives you 3. 3 is also divisible by 3. There's your candle, so you know you're done. Rewrite the square root of 9 as 3 times 3. Well, there's your pair. That's the only thing we have. So we put that on the outside. Remember, you only pick one out of those two numbers that makes the square root. So the square root of 9 is 3. So using the cake method works when you don't know all of your perfect squares. Okay? Let's go to the next page. We're just going to be doing these problems here. The square root of 24. So put 24 on the bottom layer of your cake. 24. Remember, I always try to do 2, 3, 5, or 7. Is 24 an even number? Yeah, so divide by 2, and you get 12. Is 12 an even number? Yep. 12 divided by 2 is 6. 6 is an even number. Divide by 2 again, and you get 3. Can I stop there? No, because you didn't reach the candle yet. So 3 is divisible by 3. Now you've got your candle of 1. Don't include the candle, but include all of these as your prime factors. So rewrite all of them underneath the radical sign. 2 times 2 times 2 times 3. Be careful when you are rewriting them. And you want to look for pairs. Here I have a pair of 2's. And we know, you already know 2 times 2 is 4. Maybe you know the square root of 4 is 2, but you kick one of those 2 out. Well, they both get kicked out, but you only write one of the 2. So 2 comes from that pair of 2's times this 2 doesn't have a pair. This 2 doesn't have a second person with it. So you just multiply. 2 times 3 is 6. So your final answer, the square root of 24, is 2 times the square root of 6. Just making some sense? A little bit? Let's try 72. Bottom layer of your cake. Square root of 72. Is that even? Divide by 2. You get 36. Is 36 even? Divide by 2. 18. And if you're not sure, that's when you can use your calculator. Now, I know you will have calculators on this test, but if you put in square root of 72 and you give me the answer without showing the work, you will not get credit. You have to do and show me the birthday cake method. 18 is even, divided by 2. You get 9. Is 9 even? Just say no. No. Okay. It is divisible by 3. I get 3. Can I stop there? No, you don't have the candle. So divide by 3 again, and you get 1. So you need to rewrite all of these over here under your radical. We got 2 times 2 times 2 times 3 times 3. Circle your pairs, only 2 of each type. So I got 2's here, I got 3's here, and when you have a pair, they come on the outside and they get multiplied. So this is 1, 2 times 1, 3, and the only thing I have left that doesn't have a pair is that 2. 2 times 3 on the outside is 6 times the square root of 2. Okay. All right, let's see if you can try number 4 on your own, the square root of 48. Square root of 48. Use the cake method and see what you can get for the square root of 48. Here, I'm going to give you this for tomorrow. It's not homework or anything, but we just did a couple problems on there for bell work. So when I say use the cake method, this is what we're talking about. Layers. I'm looking for layers. Come on. Len, you got an answer for number 4? Did you use that using this? You can't do that on the test. Do you understand how to do this? Are you sure? Why don't you show me right here? That's how you're going to have to do it on the test. I just want to make sure you know how to do it. Huh? Okay, so you have to, did you divide by 2? 6 divided by 3 is 2, and then 2 divided by 2, you keep going until you get 1 at the top. All right. So I'll go ahead and get this started. 48, this is a long one because it is even and it keeps being divisible by 2. So we divide by 2 every time for a long time. 6 divided by 2 is 3. Can't stop there. You don't have the candle at the top. 3 divided by 3 is 1. These are all your prime factors that go underneath. So I have 1, 2, 3, 4 2's. And I have 1, 3. Here's a pair of 2's. Here's a pair of 2's. Remember, only 1 gets multiplied on the outside. So 2 times this 2 times the square root of 3. 2 times 2 is 4 times the square root of 3. That is your final answer. Does anybody happen to get that one? Very nice. Okay. All right. So now, hopefully in your folder somewhere, you can now begin working on homework number 3. Homework number 3, right now I'm going to say it's due on Friday. Might push it back to Monday, but let's say due on Friday for now. Okay? But I want you to use this cake method. So again, some of you that turned it in early and did it another way, I need you to use the cake method. So hopefully you got a big eraser somewhere. All right? Nice job today.